This is again a goodness of fit test. What we have to check is whether the data given is distributed by this function here, f of x equals to x. Previous problem was a binomial. This is a continuous function, so we have to use the Kolmogorov-Smirnov test. Sorry to inform you, the Smirnov test has nothing to do with the vodka. It's rather the name of a mathematician. Anyway, in any case, what we have to do here is, first of all, the data we have, which you can see here, 0.58, 0.42, 0.58, 0.42, blah, 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 up to 0.64. The first thing we have to do is we have to order in increasing order. So let's start with xi, which is the data, and goes, the smallest is 0.23, 0.33, 42, 43, 52, 53, and then 58, 64, and 0.76. Now, what are the frequencies? The absolute frequencies of all these are 1, except for the 0.58, which is 2. The rest are all 1. Total of 10 numbers. Cumulative frequencies, so you have to add, as you go down, 1 plus 1, 2, 3, 4, 5, 6, 8, 9, 10. And the relative frequencies, which is fn of xi, is nothing but the cumulative frequencies divided by the total number. As the total number is 10, will be 0.1, 0.2, and so on. Simply divide by 10. Let me finish the column, 0.9 and 1. This is always 1, as this is always the total number. Now, the theoretical frequencies, if it were the distribution we suspect, is given in the problem. This is the same as the value. So for the first one, it's 0.23 here, so we put here 0.23. And the same thing here, 0.33, and 42, and 0.43, and we continue like that simply, up to the end. 0.58, 0.64, and 0.76. And now we have to take the Fn, the one we have observed, minus the theoretical one, in absolute value. So here, for example, will be 0.1 minus 0.23. In absolute value, this is 0.13. The next one will be 33 minus 0.2. Again, 0.2 here, this one here, minus 0.33. In absolute value, again, is 0.13. We fill this, and then we have 0.12, 0.03, 0.02, 0.07, 0.22, 0.26, and 0.24. And now we take the maximum. So the maximum is 26, and that's what our values. D is equal to 0.26. Now we have to go to the table. Here, the total number of points we have is 10, and the significant level is 0.05. So the critical value here is here, 0.4092. So our statistic, the value we have computed, 0.26, is less than the critical value, which is 0.4092. So here we do not reject the null hypothesis.